Do you feel the vibes?
Why don't we get into 12.6 right now? In this section, we're going to talk about the unit circle. All right, so what is a unit circle? Well, it is a circle whose center is at the origin, first of all, and it has a radius of 1 unit. Okay, as a result, all triangles drawn inside the unit circle would have a hypotenuse of 1 unit, right? So if I have a triangle here, like that, this hypotenuse, do you see how the hypotenuse is actually a radius of the circle? Well, if the radius is 1, then any triangle you draw will have a hypotenuse of how much? 1. Okay, so in fact, when we were on Zoom, I would teach this like so often that like my little one would have been like in, I don't know, kinder or first grade at the time, and so he would, until now, he walks around going, in a unit circle, the hypotenuse is always 1, which is so true, right? Okay, so now if I have a triangle, then, right, remember our lovely 30, 60, 90 triangles? I have a leg of 1 root 3. How much is the hypotenuse in this one? 2, right? Okay, so in a regular old 30, 60, 90 triangle, the hypotenuse is 2 units long. Well then, but if I have a unit circle where the hypotenuse is only 1, there is no way I can fit that triangle into the unit circle. But it's okay, because I can rescale it just like you do in Photoshop or whatever. You can just scale it down so that the hypotenuse is equal to 1, right? So if we wanted to rescale the special triangles, let's see what would happen. So here I have a 30, 60, 90. Now normally we know that this has a length of 1, and this root 3, and this would be a 2. So to make that hypotenuse into a 1, I would have to divide by what? 2, right? I would have to divide everything by 2. So now this hypotenuse becomes 1, and the new sides, the legs of the triangle, become 1/2 and root 3 over 2. Okay? Do you see how it's the same proportion as anything else, right? Because what do we know about 30, 60, 90 triangles? Whatever the short leg is, this is root 3 times that. So 1/2 root 3 over 2, right? And then whatever the short leg is, 1/2, this is twice that. So it's a 1. Okay. Now, in the case of the 45, 45, 90, I have sides of 1, 1, root 2. So what should I divide this by in order to make it 1? Root 2, root 2, root 2. So then the legs of the hypotenuse becomes 1, and then the legs become root 2 over 2, root 2 over 2. And again, if you just took, root 2 over 2, right? That's a leg. Oh, that should just be a 2. Okay? If you took this, multiply it by root 2, you would get a 1, right? So it's still in the same proportion. Okay, so now let's place a rescaled triangle inside the unit circle. I had one with a hypotenuse of 2. I scaled it down. Now the hypotenuse is 1. So this side is 1. And the vertical side is 1/2. The adjacent side is root 3 over 2. Correct? Now, when you do that, and when you have your radius over there, it intersects the circle at this point P. So let's figure out what are the coordinates of P. Okay, what are coordinates? Coordinates are basically a map of how you get to a point from the origin, right? So if my coordinates are 3, 2, that means go right 3, up 2, correct? So what are the coordinates of this? Well, I would have to go over horizontally root 3 over 2, and go up how much? 1/2. So the coordinates here are √3/2 and 1/2, right? So those numbers have two meanings. A, they are the lengths of the sides of the triangle. B, they are the coordinates of that point. It's how I start at the origin and get to that point P. Now, we filled in the coordinates. So what is cosine of 30 in this case? Remember how it was always adjacent over hypotenuse? If your hypotenuse is 1, do you have to do the over hypotenuse part? No. So what's the cosine of 30 then? Just √3/2, just the side itself. And what's the sine of 30 then? 1/2. So what conjectures have we come up with then? What conjectures can we come up with? What happens when in a unit circle, when the hypotenuse is 1, the sine and the cosine are just the what of the triangle? They're just the sizes of the legs of the triangle, right? So in a unit circle, okay, cosine of theta is just the x coordinate. Sine of theta is just the y coordinate. Furthermore, remember how we had SOHCAHTOA like this? Now, when the hypotenuse is 1 in a unit circle, I can actually drop the h's. So it literally becomes sine is the opposite, cosine is the adjacent, tangent is still opposite over adjacent. So I eliminate over hypotenuse altogether. Cool? Cool. Okay, so each point on a unit circle has the form cosine theta, sine theta. So we're going to fill this out, but we're not going to do it like by, what do you call it? We're not, okay, so here's how we're going to do this. So take a look at this first one here. This is 30 degrees, which is pi/6, correct? Okay, now, from now on, all my right triangles, they're going to have hypotenuse of 1. So the 30, 60, 90, right? It's going to be a side of 1/2 √3/2. That's all we're going to remember now. No more 1 √3 and 2. No more of that. 1/2 √3/2. So now, this is the 30-degree angle, and I want to know what are the coordinates of that point. From the origin, how do I get to that point? Well, I have to go over horizontally a little bit and vertically a little bit. So now, my two options are I can either go √3/2 or 1/2. Now, if I have 30 degrees, it means I go horizontally longer and up much shorter, right? Because that's how it looks. So I go horizontally longer and up shorter. Okay? So those are the coordinates over there. Now, let's go to its corresponding point here. This is 150 degrees. How much is it in radian? Not pi/6, but how much? 5 pi/6. Okay. So here too, I have to go horizontally longer and up shorter. So I have to go negative √3/2 and up 1/2. Okay, now here if I have 210, this is 7 pi/6, correct? I have to go horizontally negative √3/2 and down how much? Negative 1/2. Okay? Then if I'm at 11 pi/6 or 330, to get to that point, I have to go horizontally √3/2 and down negative 1/2. Okay? You guys see how to do that? Awesome. Okay. So what if I'm at here 60 degrees or pi/3? Now look, I have to go again horizontally and up. So horizontally this time I go a little bit, but much higher vertically, right? So to get to this point right here, I have to go over 1/2 and up √3/2. Okay? So how do I get to this one, 120, which is how much? 2π/3. How do I get there? How much do I go horizontally? -1/2. And how much do I go up? √3/2. What if I'm at 240, which is how much? 4π/3. Okay, how much do I go horizontally? A lot or a little? A little, so -1/2. And how much do I go down? -√3/2. So lastly, if I'm at 300 degrees, which is 5π/3, do I go horizontally a little or a lot? A little, so 1/2, and then -√3/2. Are you ever going to memorize this unit circle? Say no. No. Don't memorize it. And I know there are people out there who will tell you, oh my God, let me tell you a quick way to fill out the unit circle. Okay, big deal. Nobody is ever going to ask you, fill out this unit circle. What we're going to ask you is, okay, 7π/6, go. Now, just to do 7π/6, is it worth it to draw the whole darn thing every single time? That's just silly, right? So 7π/6, you're like, okay, I know exactly where it is. I go more horizontally, √3/2, and down a little, 1/2. Okay? All right. So why don't we do the π/4s? So 45 degrees. Okay. For the π/4s, I go horizontally and vertically the same exact amount. Okay. So √2/2, √2/2. 5π/4, which is 135 degrees. How much do I go? Right. Okay. And then 7π/4, which is 215 degrees, both negative. And then how much is the other one? 315 degrees. I was right. Oh, no, this is 225 degrees. I was wrong. So how much is it in radian? Oh my God, this is 7π/4. This is 5π/4. I'm sorry, guys. I'm trying to rush through this. Okay, so again, positive √2/2, negative √2/2. So now all of it becomes the same. It's all coordinates, right? So if I were to ask you, what is the cosine of 2π/3? You say, okay, 2π/3, that's here, right? Okay, cosine is the x-axis. Cosine is the horizontal. How much horizontally do I need to go to get to that point? -1/2. So that's how we do it. So now they all become coordinates. If I'm at 0 degrees or 0π, how do I get to that point? 1 horizontally, 0 vertically. Do you see now why we just choose 1? Because later on it's going to be the unit circle. Okay, so how do I get to 290 or π/2? 0, 1, right? And then pi, correct. And 270, right. Okay, and then at 360 or 2π, it's the same. Okay. 1 second. Okay. All right, so let's do some of these. Okay. Suppose the terminal side of an angle theta intersects the unit circle at the given points. Find the values of cosine and sine for each angle. Then find the measure of the angle in radians and degrees. Okay, so if this is the coordinate for where it intercepts, right? like it's one of these coordinates. We know that the x value is always cosine and the y value is always sine. So we say cosine of theta is root 3 over 2. Sine of theta is 1/2. Now, okay, so to get to this point, I have to go horizontally root 3 over 2 and up only 1/2. What angle would I have made? 30 degrees. Or pi over 6. Okay? So 0 and -1, where would I land? What's the cosine? Cosine is sine. And so that would have been, is it 180?
180. Oh, it's 270.
It's 270. How much? 3 pi over 2. Okay. So now, find the exact value of each of the following. So obviously, these are non-calculator questions. Okay. 135. So here's what you want to do. When you do it this way, it really eliminates so much. Okay. 135 is here. So now, how do I get to that point?
What are you trying to find?
The sine of 135.
Oh.
So how do I get to that point from the origin? Well, I have to go, how much left do I have to go for sine of 135? Okay, so which one of the triangles is that? Is that the root 2 over 2 or the... It's the root 2 over 2. So I would have to go root 2 over 2 to the left. And how much would I have to go up? Root 2 over 2. So I have to go up root 2 over 2, right? So this is root 2 over 2. Positive, because it's sine. It's the vertical. Yeah? Okay, so let's do another one. Hey, okay. 7 pi over 3. Which quadrant does that fall in? It is first, you're right. Okay, hang on. Okay, so 7 pi over 3, what quadrant is it in? We said 1, right? So right there. And it's the pi over 3. So is the pi over 3, you know, the bigger angle, or is it the smaller angle? The bigger angle for sure. So that means to get to that point, do I have to go more horizontally or vertically? Vertically. Okay, so is cosine horizontal or vertical? Horizontal. So I only have to go 1/2 to get to that point horizontally. Do you see how that works? Right? So the question we're asking ourselves is, how do I get to that point? Well, I have to go this way 1/2, and I have to go up root 3 over 2. Do you see? I no longer do opposite over adjacent, hypotenuse, whatever, blah, 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 none of that. I only have a couple of sizes that exist to me now. And those are the 1/2, the root 3 over 2, and the root 2 over 2. Unless it's a quadrantal angle, then you have the zeros and the ones. Okay, so tangent of 5 pi over 6. So what quadrant is 5 pi over 6 in? It's in 2. And is that the bigger or the smaller angle? Smaller. Okay, so to get to tangent of 5 pi over 6, how much do I have to go vertically? Vertically. 1/2. How much do I have to go horizontally? Negative root 3 over 2. So I have to go negative root 3 over 2 and then 1/2 upward. So if tangent is opposite over adjacent, then this becomes 1/2 over root 3 over 2, negative. So this becomes negative 1 over root 3, negative root 3 over 3. Okay? Okay, cotangent 5 pi over 3. What quadrant is 5 pi over 3 in? 1, 2, 3, or 4? 4. 5 pi over 3, and it's the bigger angle there. Okay. So how would I get to that point? I go horizontally a little bit, but a lot more vertically, right? So cotangent is adjacent over opposite. How much is the adjacent here? 1/2 over negative root 3 over 2. The 2's cancel, so I have negative 1 over root 3, negative root 3 over 3. Okay. It's the tangent of 5 pi over 6. So tangent of pi over 6 and cotangent of pi over 3 are the same. Okay? And then you'll learn next year in pre-calc that that's actually like an actual thing. Okay, so let's do another one. Secant of 120. What quadrant is 120 in? It's in quadrant 2. So what's the higher value, the horizontal or the vertical to get to that point? Okay, so now it's either one or the other. So you have to decide on one. So to get to 120, is it vertical is higher? Okay, so now secant is the reciprocal of the cosine. So how much would the cosine be here? Negative 1/2, right? So to get to that point, I go over 1/2 and up root 3 over 2. So this would be negative 2. Okay, so let's do another one. Cosecant of negative 3 pi over 4. So negative 3 pi over 4. So let's see. I have 1 pi over 4, 3 pi over, oh shoot, it's negative. Yep. So 1 pi over 4, 3 pi over 4 here. Okay, because it's the pi over 4, I go the same amount horizontally as I go vertically. And that amount is root 2 over 2. Now this is the cosecant. Is it going to be positive or negative? Negative. So it's going to be, this is negative root 2 over 2, right? So it's going to be 2 over root 2 negative, which is negative root 2. Okay? Questions? Okay. All right, so let's do this next one. Cosine of 480. Okay, so 480, we have to, if you start here and I go 360, I have to go 120 more. Okay, so how do you get to this point? Is cosine the horizontal or the vertical? Horizontal. So to get to that point, I have to go over by 1/2 and up root 3 over 2. But I go over negative 1/2, right? So this is going to be negative 1/2. Lastly, okay, sine of negative 3 pi over 4. Negative 3 pi over 4, we're at that point again, like we did for f. Sine is the vertical, so it's how much you have to go vertically to get to that point, and it's negative root 2 over 2. Oh boy. Okay, tangent of 690. Ooh, that's a lot. Okay, so let's see. So here's the unit circle. So let's see how we get to 690. This is 0. If I go 360, how much more do I need? 330, so I go all the way there. So I have 30 more left, right? So now, how would I get to this point? Well, I would have to go horizontally, root 3 over 2, and down negative 1/2. Tangent is opposite over adjacent. So negative 1/2 over root 3 over 2. 2's cancel. Negative 1 over root 3. Negative root 3 over 2. Okay, cosine 17 pi over 3. Oh, that's a lot, 17 pi over 3. Okay, so again, use mixed numbers. 17 over 3 pi This is what? 5 and 2/3 pi. Okay, so if I start here, I go 2 pi, 4 pi, 5 pi, 2/3 of a pi, we're all the way down there. Okay, is cosine horizontal or vertical? Horizontal. Cosine is horizontal. So to get to pi over 3, do I have to go horizontally the smaller amount or the bigger amount? Smaller amount, which is a half. Okay? Do you see why I don't want you drawing the unit circle? This is how we need to figure this out. Okay? So if you can sit and you can like reproduce this, it's not impressive to anybody. It really isn't. Okay? Because you just, I mean, I can take any first grader and I can just have them memorize how to write a unit circle. Have they learned any trigonometry? No. Okay? So that's really the thing. Okay. Now, we're going to do this one little thing. Okay, we're going to start graphing this. Okay, so here, you look at the horizontal axis. It's x. These are your angles. It goes 0, pi over 2, pi, 3 over 2 pi, and 2 pi. The horizontal axis is the y value. So we're going to graph sine of x. So for 0, okay, y is going to be sine of x. So basically, we want sine of 0, which is how much? 0. So 0, remember, it's the same thing. How much? Where is 0 degrees? Right here. Sine is the y value. How much do I go vertically to get to that point? 0. Okay, next, pi over 2. Pi over 2 is here. Again, we're doing sine, only vertical. How much do I need to go vertically to get to pi over 2? 1. Okay, what about pi? How much do I go vertically to get to pi? 0. How about 3 pi over 2? How much do I go vertically to get to? And 2 pi? Fabulous. Okay, so let's graph this. Sine is 0. Sine of 0 is 0. At pi over 2, sine is 1. At pi, sine is 0. 3 pi over 2, sine is negative 1. 2 pi, sine is 0. Okay, and take a look at what happens now. This goes like this, and like that. Oh my God, what an absolute beauty. Look at that. Look at how beautiful that is. It's an actual wave. This is a sine wave. You should all remember this moment, okay? April 16, 2:07 p.m. when you graphed your first ever sine equation. Look at that, okay? Happens to fall on my son's birthday. You guys are so lucky. I know. Yeah, okay. So, oh, and he's becoming 14, which is like 3.14. So like, so meaningful. Okay, right? So this is what it looks like. So, so look at this. The y value, right, is 0 here, and the y value is 0 here. Then the y value starts to increase until it's 1. The y value here starts to increase until it's 1. And then the y value starts to decrease to 0, just like here, decreases to 0. And then, you know, the pattern starts again. So now let's do a cosine. Cosine of x. So cosine, remember, is the x value. So to get to 0, how much do you need to go horizontally? 1. To get to pi over 2, how much do you go horizontally? 0. To get to pi, how much do you go horizontally? Negative 1. 3 pi over 2 horizontally? 0. 2 pi? 1. Okay, so when x is 0, cosine is 1. Pi over 2, it's 0. Pi is negative 1. 3 pi over 2 is 0. 2 pi is 1. Okay, let's make this now. Remember, this is not a V. This is part of a wave. So let's pretend this is part of a wave. And look at that. Okay, it's just like one part of this wave. Okay, so there we go, sine and cosine. So now if we were to continue these, you know, they would just keep going forever and ever and ever in both directions. What do you notice here? There is a horizontal axis. We call this the axis of oscillation. They only go as high as 1 and as low as -1. And this wave oscillates or goes back and forth around that horizontal axis. Axis, maximum, axis, minimum, axis. Okay? 0 max, 0 min, 0. Same with this. It goes as high as 1 and as low as -1. And it oscillates around this axis. So it goes from the maximum, 0, minimum, 0, maximum. So up, down, up, down, up, down. Okay? Beautiful. Because tomorrow, all we're going to be doing is graphing. Okay? The next class, all we're going to be doing is graphing. So this is a little bit of that. So these, have you noticed how much of these we're doing? Okay? You really have to be quick at these. Like quick, quick, quick. Okay? All right. So we'll stop here today.
Press start.